Hello everyone, this is Dr. Lennon, and today we're going to look at solving linear equations. Solving linear equations probably you've had exposure to, so this is probably just most likely a review. But let's first just kind of outline the plan. We're looking at linear equations, which just means involving only variables and regular numbers. No powers of those variables, just the single variable by itself being multiplied, added, and subtracted or divided with things. So the strategy is essentially to first move all terms with a variable to one side of an equation. And regular numbers to the other side. So this is done using just addition or subtraction, no multiplication or division at that point. And then once you've done that, the second step is to just multiply or divide. So that the coefficient of the variable is 1. So basically all these problems are kind of done essentially in 2 steps. However, sometimes there will be some distributing we need to do to collect like terms. So really maybe there's more like a step 0, multiply to remove all parentheses via the distributive law. But fundamentally, really, you're just doing these 2 things. And that's all there is to solving linear equations. So we'll just go through a bunch of examples. So we'll start off kind of with some easier ones and then see how they can become more challenging. So solve each linear equation. So the first one, we have 5x plus 8 equals 23. So essentially we have the 5x, that's the term with the x's, and then 8 and 23 are regular numbers. So we want to get those on the same side of the equation. So we're going to accomplish that by subtracting 8. So we have 5x equals 15. Now we're on step 2. We want to just get x by itself. X is being multiplied by 5 on the left, so we're going to divide by 5. So we divide by 5, and we get our answer, x equals 3. And that's all there is to it. So when they're simple with no parentheses or no fractions, they can be done very, very quickly. Let's look at another one of these. Let's say B. Let's say we have 6x minus 16 is equal to 2x. Now, it's up to you really to pick which side you want x's to be on. The easiest way is probably subtracting 6x. That way your x's end up on the right and you're just left with that minus 16 on the left-hand side. But you can also do it in 2 steps by, say, adding 16 and subtracting 2x. But it should be a step longer if you do it that way. So you end up with just the minus 16. 6x minus 6x goes away. 2x minus 6x leaves you with minus 4x. Now we're multiplying x by negative 4, so we'll divide on both sides by minus 4. And we're left with our answer here as well. X is positive 4. So another quick one. Not too much to say there. Let's look at C. Let's say we have 15x plus 20 equals 13x minus 8. Now here we're going to want to do 2 things. We're going to want to move the x's to one side and the numbers to the other side. And we can do that in one step. We just have to pick where we want the x's to be. So let's say we want to move the x's to the left. So I'd want to subtract 13x from both sides. So that'll put the x's on the left. The x's will cancel on the right. But I don't want this 20 on the left end because that's the side I've chosen for my x's. So what I'm going to do is I'm also going to subtract 20, and that'll move my regular numbers to the right. So 15x minus 3x will leave me with 2x. 20 minus 20 goes away. 13x minus 13x goes away. And minus 8 minus 20 becomes minus 28. And then I just have to go through the final step of dividing by 2. And I get my answer. X is negative 14. For D, we're going to look at the first one where maybe we have a set of parentheses. Nothing too dramatic, but we have x plus 2 equals minus parentheses 7x plus 7. So we can't start moving things to the left and the right side of the equation until we get rid of those parentheses, and we get it just by multiplying the negative through. So this will become x plus 2, and that's equal to minus 7x minus 7. And now we go through it like we have the previous problems. So let's say we want to move the x's to the left. So that would amount to adding 7x to both sides. So my minus 7x and plus 7x will go away on the right. And so then I want my regular numbers on the right-hand side, so I'll need to subtract 2. So x plus 7x makes 8x. 2 minus 2 goes away. Minus 7x and plus 7x goes away. And minus 7 and minus 2 is minus 9. And then I'm just going to divide by 8 to get my answer. X is negative 9 over 8. So there we perform the distributive law with just the negative sign. It can also be done with numbers as well. So let's just review that. So the distributive law. It says if there's basically two versions. There's the left distributive. If you have A times B plus C, this can be written as AB plus AC. Maybe I should make these arrows. Dots sometimes can be confusing. There's no multiplication going on or anything like that. You can also distribute from the right-hand side. So if you had, say, A plus B times a C on the right, this would be AC plus AB. You're basically multiplying the C across the parentheses there. So that's what we were doing in the previous problem. So just in case you forgot that, that's the distributive law, and it'll come up more frequently in the future problems. So let's say solve each linear equation. So let's say I have 3 times 4x plus 2, and this is equal to 30 minus x. So I have to get rid of the parentheses on the left-hand side, so I'm going to distribute that 3 across. So I do 3 times 4x, and I get 12x. And then I do 3 times 2, and I get 6. And then I have 30 minus x on the right-hand side. So again, you want to pick your side. There's always two choices. I generally like to do whichever one seems quicker or whichever one keeps the coefficients positive. So I'm going to add x to both sides to start to get rid of the x's on the right-hand side of this equation, which means I'll have to subtract my 6. So you can kind of do it in the reverse order on the other side since they've written the numbers backwards. Usually you'll see the x's in front, but this time they didn't. So we want to subtract 6 and add x. So we'll go ahead and do that, subtract 6 and add x. We just did it in the other order, but addition is commutative, so that's not causing any issues. So 12x plus x makes 13x. And then on this side, 30 minus 6 makes 24. So now I just divide by 13, and I am all finished. So x is 24 over 13. And that's my answer. That doesn't right. Okay, B, let's have another look at one of these. It's going to drive me crazy, a little dot there. So for B, we'll have maybe, this one will distribute on both sides even. 11 times the quantity 2x minus 6. and that will equal minus 12 times x plus 14. So distributing the 11 on the left, we have 22x minus 66. And on the right, it's important to note that that negative 12 is all one number. So we not only distribute the 12, but also the negative. So we have negative 12 times x, which is negative 12x. And then we have negative 12 times 14, which is going to be what? 140 and 28 minus 168. And then again, we want to do as usual. So I'm going to add 12x to both sides to start and add 66 to move the 66 over. So I have plus 12x plus 66. So I have, 34x equals minus 102. And divide by 34. You end up with, I think that's x is equal to negative 3. Again, I did all this mentally, so maybe I'll check the calculator just to double check my answers there, that I didn't mess up 12 times 14 or the division. And yeah, it looks all right to me. Yep, all set. Okay, so let's go through one more where possibly we have some distributing to do, and then after that we'll look at maybe some equations that involve fractions, and we'll see a trick there. So see, let's say we have 8x minus 2 times the quantity x minus 2, and that equals 6x plus 2. So the first thing we want to do is we want to distribute the minus 2 to get rid of those parentheses. So we have 8x minus 2x. Minus 2 times minus 2 now makes plus 4, and this is still equal to 6x plus 2. So I can now combine 8x minus 2x gives me 6x plus 4, and on the right-hand side I get 6x plus 2. So you might already notice that this equation, it's impossible for it to have any actual solutions. If you try to subtract 6x, let's say, you end up with 4 equals 2, which is impossible. So for that reason, we say that this equation has no solutions. This is what's called an inconsistent system. So this is an inconsistent system. Or inconsistent equation. So there's two oddities there. You can have inconsistent, and you can also have what's known as an identity. So let me give you an example of an identity. So let's say we have 5 times x minus 3 plus 2x, and let's say this equals 7x minus 15. Well, as we expand, we would have 5x minus 15 plus 2x, and that'll equal 7x minus 15. And then 5x plus 2x makes 7x. So we end up with 7x minus 15 on both sides of the equation. Now that's going to be true no matter what value you plug in for x. If you plugged in 0, you would have negative 15 equals negative 15. If you plugged in 1 for x, you would have 7 minus 15, which is negative 8 on both sides. So this is going to work for all real numbers. So all real numbers are actually a solution here. So all real numbers are the solution set. And this is known as an identity. Usually what we're solving, we're just getting one number. That's known as a conditional equation. And you can really think about the way, if you drew 2 lines in the plane, there's 3 possibilities. They could intersect at exactly 1 point. So if they intersect at 1 point, that's like one solution. If they were parallel, they would have no solutions. And if you would draw the lines right on top of each other, you would have an infinite number of solutions. So that's maybe how you can kind of rectify the 3 possible outcomes to solving linear equations. Okay, so now let's look at let's say equations, linear equations with fractions. So there's a nice trick here. And what you want to do is multiply both sides by a GCF of the denominators to temporarily eliminate the fractions. And doing this is much easier than getting a bunch of common denominators for the fractions and adding them or subtracting them. So we'll see that in the next couple of examples. So let's say solve each linear equation. So A, let's say we have minus 8/5 x plus 4x, I forgot the x, and that, say, is equal to 1/4 x plus 43 over 4. So we want to get rid of the fractions, so we just need a common denominator of 5 and 4. So basically, we're just going to multiply both sides by 20. That's a common multiple of both of those fractions. So when we do that, all the fractions will disappear until the very last step. And remember, we have to distribute here. So when we have 20 divided by 5, that will leave us with 4. So we'll have minus 8x times 4. And then the next one will have just 4x times 20. And then when you go through the next one, 20 divided by 4 is going to leave you with 5. So we have 5x. And then 20 divided by 4 is again going to leave you with 5. So we have 5 times 43. So now we're just left with this normal looking linear equation where all the fractions have gone. So we have minus 32x plus 80x, and this will equal 5x plus 215. And so 32 plus 80, that's going to leave us with 48x equals 5x plus 215. And we just subtract 5x on both sides. So we have 43x equals 215. And then we divide by 43. And what do you know? I think that comes out exactly to 5. Yep, sure does. So let's do one more of those. So let's say 5 over 6x minus 1/5 x plus 4 equals 7 over 10x. So what is the greatest common multiple, or least common multiple rather, of 6, 5, and 10? Well, those all go into 30, right? So 30 would be what we'd want to multiply both sides by here. So we take 30 times 5 over 6x minus 1 over 5x plus 4, and that'll equal 30 times 7 over 10x. So we distribute on the left, 30 divided by 6 is 5, so we have 5 times 5x. Then we have 30 divided by 5, that leaves us a 6x in the middle, and then at the end we just have 30 times 4. On the right-hand side, 30 divided by 10 is 3, so we just have 3 times 7x. And then we can go from here. So we have 25x minus 6x plus 120 equals 21x. So 25x minus 6x leaves us with 19x plus 120 equals 21x. And then we'll subtract by 19x. And so we have 120 equals 2x, and we can divide by 2. So we have just 60 as our value of x. Okay, so there's one more type that I'd like to look at, and that's just one that involves decimals. And there's not too much advice that I give there. I'd say just make sure you use your calculator. But there's no real trick or different technique. We just follow the same strategy that we did for the basic two-step ones. Get the x's on one side, the regular numbers on the other. Distribute and collect like terms if you need to. So we'll just do one more problem. Let's say we have 0.45x plus 0.05 times 8 minus x. And let's say this is equal to 0.10 times -12. Okay, so we just multiply through. There's two things we can multiply right now. So we have our 0.45x, and then we have 0.05 times 8. So that's 0.4 minus 0.05x. And then the right-hand side just comes out to minus 1.2 when you multiply those two numbers. So on the left, we can collect 0.45x minus 0.05x is just 0.4x plus 0.4 equals minus 1.2. So we're going to want to subtract that 0.4. So we have 0.4x equals minus 1.6 when you add those two. And then we're just dividing by 0.4. So that comes out to multiply. So that comes out, yeah, it's just 4. -4 rather. X equals -4. And that's it. So usually the decimal ones aren't so difficult. You just add those together using a calculator. The ones with fractions tend to be a little bit trickier. But anyway, that's it for linear equations. So hopefully this was a good review. And if you have any questions, please let me know. Otherwise, this is Dr. Lennon signing off.